Well, we're here to try one of the most famous problems you'll see in Math 212. Let's just say we had 30% of a certain group, let's just say boys. 30% of the boys said yes to something. Doesn't matter what it was. And let's just say that it really doesn't matter here. I'll do 73% of the girls in a class or in a school said yes. Is it possible for there to be 25% of all students saying yes? I'll let you think about that for a moment. Is it possible, again, 30% of the boys said yes, 73% of the girls said yes. Is it possible that 25% of all students said yes? Well, let's just say for a second that the entire school was boys. If that's the case, if the whole school was boys, then there would be 30% of people saying yes. And this 25% is lower than that. And once we start adding some girls to this chunk right here, if it was all girls, would be 73%. So as we continue mixing some boys and girls together, we're going to get some number in between them. We're going to have to get some percentage between the two. So 25% is not possible. Worst case scenario on the low end is 30%. Worst case scenario on the high end is 73%. So we have to get some value between those two. Okay? So now let's see if we can kind of back up a little bit and go back to the question. What if we didn't have 25%? What if we had some other number? So is it possible then that we could have 67% of all students say yes? Is that possible? Well, notice 67% is between these two. So yes, that is possible. Of course, the question then becomes, how is that possible? Well, let's turn this into a nice equation. So if there's 30% of the boys, let's make that into a nice little piece here. 30% of all the boys, I'll let the variable b represent boys. And by boys, I mean the number of boys in the school, not the number who said yes. This piece would represent the number who said yes. I'm going to take those boys, and I'm going to add 73% of all girls. So G is going to represent the number of girls. All right. And what do we want that to equal at the end? We want that to equal. That is really bright, so I'll tone that down a little bit. We want that to equal 67% of all students. Oh yeah, that's much less bright. Which would be boys plus girls. So here's our 30% of all boys. This is the number of boys who said yes. Here is the number of girls that said yes. And over here on the right, we have the number of total students who said yes. Well, let's do a little multiplication and see what we end up with. So over here, if I multiply this side out, I'm going to get 0.67b plus 0.67g. And of course, that equals this piece, 0.73g plus 0.3b. Now let's go ahead and subtract 30% of the boys on each side. And we'll also subtract then 67% times the number of girls from each side. And at the end, we're going to have, over here, we will have 6%, 0.06G is equal to, over here, 0.37B. Now multiplying both sides by 100 gives us an equation that's a little bit nicer to handle. 6 times the number of girls is equal to 37 times the number of boys, which means, to us, we have a nice ratio. If we divide both sides by 6 and both sides by b, we'll have the ratio G over b is equal to 37 over 6. Now you can check this. Remember that multiplication property, basically finding a common denominator here. We can kind of see that 6G is going to equal 37B when we multiply it out. So this actually is biconditional. You can go both directions here. But what does this do? This gives us our ratio. If we were to have 67% of all students say yes, then we must have 37 girls for every 6 boys. And that is how you find the ratio of girls to boys in a problem like this. All right, well, go ahead and check out the next clip if you're going to try to find the number of boys and the number of girls, the minimum number, that is, in a school. So check that next clip out and give this one a shot again as you look back through your tests and through the homework. Off you go.